and welcome. My name is Aditi Roy, longtime business and news reporter and founder of Aditi Roy Media. Today, I'm thrilled to bring our next speaker onto the stage, Waymo co-CEO Dmitri Dolgov. Dmitri was one of the founders of Google's original self-driving car project, and he's going to take us through an adventurous ride through the history of autonomous driving and where it will lead in the future. Please join me in welcoming Dmitri.
Thank you. Hi, everyone. Good afternoon. It's great to be here. Most of the AI that people talk about nowadays lives in the digital world, and it is incredibly impressive. It can write code, it can diagnose illness, compose music, create videos, and so much more. But the AI that we are building at Waymo doesn't live on your screen. It lives in real life, among people, in weather, in traffic, in motion. So today, we'll talk about the most advanced application of AI in the physical world, Waymo's autonomous vehicles. But why do we need autonomous vehicles in the first place? Well, because when it comes to road safety, the status quo is unacceptable. Every year, more than 1 million people lose their lives to road collisions across the world. To break that down, every 26 seconds, a person loses their life to a road collision. This is staggering. And the vast majority of these tragedies are due to human error. We can do better. And this is why we founded Waymo more than 15 years ago, to challenge the status quo and to build a safer mobility option for all. Let's go back to those early days for just a minute. It's quite fitting that we are here today at Google I/O because we started in 2009 as the Google self-driving car project. In fact, this very parking lot where we're sitting right now, next to the Shoreline Amphitheater, is where in 2009 we did our very first car bring-up and testing, as well as an occasional autonomous race. So check this out and see if you can spot the amphitheater in the background. I honestly did not know that you could drift a Prius until then. And by the way, those cones that you see lying down on the ground, they're supposed to be like that. We did not hit them. They're pointer cones. They tell you which way you're supposed to go, and we use them to set up the course to allow human drivers to compete against our autonomous racing Prius. When we started in 2009, we had a pretty small team. It was about a dozen engineers who came together with one goal: to prove that autonomous vehicles were possible. Here's some pictures of the team from those early days. There's a younger version of me. I practically lived in the car for the first year or so, and nowadays, we hear from our Waymo riders that many of them like to use Waymo as their mobile workspace. So I like to take credit for actually starting that trend back in 2009. Many of us at the time came from the so-called DARPA Grand Challenges. Those were competitions in early 2000s that really pushed forward the state of the art in robotics and autonomy. So that meant that many of us had some experience in the autonomous vehicle space, and it was not entirely new to us. However, this was different. This wasn't about winning a race in the desert. This was about proving that autonomous vehicles can work on real roads, and if so, redefine the future of driving. So when we started, our first goal was to learn as much as possible about this space. And to that end, Google's founders, Larry and Sergey, gave our team 2 challenges. The first one was to drive 100,000 miles in autonomous mode. And at the time, this was orders of magnitude more than anyone has done. And the second challenge, and that one actually turned out to be the more difficult one, was to drive 10 routes. Each one was about 100 miles long, and we had to complete each one from beginning to end with no human intervention. So we're super excited when we managed to finish both of these challenges in about a year and a half. So again, technology of 2009, a team of about a dozen engineers, 18 months, and we got it done. However, there's a massive difference between doing 10 routes once or building a system that just works most of the time versus building a reliable, scalable, fully autonomous service with no human behind the wheel. And the challenge isn't just building the tech, it's proving that it's safe. It's earning the public's trust. It's building a product that people love and actually want to use. So as you can see, it's been a long road for us, but we've always built for the long game, layer by layer, never cutting any corners or compromising on what really matters. And that's what got us to where we are. And today, Waymo is operating a 24/7, fully autonomous ride-hailing service with no human behind the wheel in 4 major US markets: San Francisco, Phoenix, LA, and Austin. Thank you. And soon, bringing it to Atlanta, Miami, and DC, and many more cities after that. Every week, we're serving more than 250,000 fully autonomous paid trips. And we're growing exponentially. This is 5 times higher than the same time last year. In fact, we just hit a major milestone. We crossed 10 million fully autonomous paid trips. And half of those took place just this year alone in less than 5 months. This is what exponential scaling looks like. But we're just getting started. With every mile driven, we're also making our roads safer. The data speaks for itself. When it comes to serious collisions, anything involving an injury or airbag deployments, the Waymo driver is about 5 times safer than humans. And for anything involving pedestrians, the results are even stronger. Now, this data purely looks at rates of collisions with no consideration of who is at fault. If you take that into account, the results are even stronger. A large insurance company, Swiss Re, has analyzed the Waymo data and used insurance claim as a proxy for fault. And they found the Waymo driver to be about 10 times better than humans. Now, this is a safety record that we feel proud of. And with more than 50 million fully autonomous miles under our belt at this point, we feel like we're actually starting to realize our mission of making our roads safer. Now, let me show you a couple of examples of the types of situations and behaviors by the Waymo driver that lead to these overall numbers. This first example is from Austin. What you're seeing here is a view from a car, cameras on the bottom, or how the scene would appear to a human driver. And then at the top is how the Waymo driver sees the scene. So keep an eye on that scooter rider up ahead and to our right. All of a sudden, they lose their balance and stumble onto the road right in front of us. The Waymo driver reacts immediately, swerves to the left, keeping both the scooter rider and our passengers safe. Here's another one. An oncoming truck swerves into our lane. The Waymo driver again reacts immediately, nudges onto the shoulder, avoids what could have been a head-on collision. So this superhuman performance is the result of the state-of-the-art AI that is the backbone of the Waymo driver. Now, there are a few things that make autonomous driving a uniquely challenging AI problem. There's 3 main aspects of that. The first one is that we operate in a complex, messy, noisy physical environment. We have to deal with different weather conditions: rain, fog, dust storms, and so forth. And we share the roads with humans, who often act unpredictably and sometimes recklessly. The second aspect is that it is a safety-critical environment. So any mistake can have very serious and very immediate consequences. That means our tolerance for errors is very, very low, and we need a lot of nines in our performance across the entire stack. And the last aspect is that it's a real-time environment. Like, our AI doesn't run in a data center somewhere where it can take a few seconds to process all the data, crunch the numbers, and come up with the right driving decision. It all happens in real time on board the vehicle, where milliseconds matter, especially when we're moving at high speeds. And all of the hard problems are in the long tail of driving, the rare events. It's things like a grill falling off a truck in front of you on a freeway, or trees coming down during a storm, flooding, toddlers on the loose, and so much more. In fact, every day today, the Waymo driver encounters situations that many of us would never see in a lifetime of driving. So how do we go about tackling this problem? Well, because we operate in the physical world, it starts with sensors. At Waymo, we use three main sensing modalities: LiDAR, cameras, and radars. Each one has a full 360-degree coverage around the vehicle, and they have different physical characteristics, so they complement each other very nicely and give us redundancy. Here's what the data actually looks like. Again, cameras on the bottom, and at the top is what we get from our state-of-the-art, custom-designed LiDAR and imaging radar. So these yellowish-brown 3D shapes is what we get from our LiDAR, and then this heat map on the ground is what the world looks like to our imaging radar. And working together, these sensors can give the Waymo driver superhuman sensing ability. Let me show you an example. This is from Phoenix. We're driving in a dust storm. This is what the scene looks like to our high-resolution, high-dynamic range camera, not unlike what any of us would see if we were to drive there. This is what it looks like to our LiDAR for that same frame. You can much more clearly see that there's a pedestrian standing on the side of the road. So imagine they were to step onto our path. This early detection can make a really big difference in how the situation plays out. But as great as these sensors are, they're just that, sensors. They give you raw, sometimes noisy, measurements of the world around you. So it all comes down to our AI to interpret all of that data and make good driving decisions. In fact, AI and ML has played a key role in our technology from the earliest days. And over the years, we've seen multiple waves of innovation and big breakthroughs that helped us improve the Waymo driver, and in many cases, we actually pushed the field forward ourselves. One of the big early breakthroughs was due to the advance of convolutional neural nets, or ConvNets, which took off about 2013. And they were a game changer in computer vision. And they really gave us a big boost on the perception side of things. Then, in 2017, came an even more profound change: transformers. This is the foundational architecture that powers all of the large language models that we see today. And for us, it gave us an additional boost in perception, but even more importantly, it led to some major breakthroughs in the area of understanding intent, making predictions about the behaviors of others, and applying ML to this problem of decision-making and planning. It turns out that modeling the interactive aspects of driving, the social aspects of driving, is not unlike modeling a conversation. Except instead of words, you have states of objects. And instead of sentences, you have trajectories of those objects. And then most recently, large language models and visual language models, LLMs and VLMs, have opened up entirely new possibilities for us that allow us to combine the expertise of the Waymo AI with the general world knowledge of VLMs. So how can we use VLMs for autonomous driving? Well, one use case is just understanding language, understanding text. Take this parking sign, for example. It's a little scary, a little daunting. By the time you're done reading it and decoding it, you're probably getting towed already. So we asked Gemini, it's Wednesday at 4 p.m., can you park here? Anybody? Yes, no? while Gemini comes back with the correct answer right away. Another area where using VLMs is very helpful for autonomous driving is just general scene understanding. For example, you can give this image to Gemini and ask it to interpret what's going on and what driving actions one should take here. And it comes back right away with a deep understanding of the context of the scene, as well as some high-level description of appropriate actions. So naturally, the next step is to go for deeper integration. And last year, we published some research that we called EMMA that does just that. Essentially, it is an end-to-end ML model that takes in input from multiple cameras and as output produces a trajectory. And almost out of the box, it drives reasonably well. Now, this is a research model. It has certain limitations. It's not safe enough to drive on its own without a human driver, but it illustrates the huge potential of large multimodal language models for autonomous driving. So to leverage that potential, we've been developing what we call the Waymo Foundation model, which combines the AV domain expertise of the Waymo AI backbone and the general world knowledge of VLMs. It's essentially an encoder and decoder model. The job of the encoder, or the perception side on the left, is to take the data from all of our sensors, the lidars, the cameras, the radars, and to compress it or encode it into a representation that contains all of the information that's relevant for the task of driving. And the decoder, the part on the right, that's the generative part. That's the part that understands the social interactive aspects of driving. That can model behavior. It can predict what other people will do. It can generate trajectories and driving behaviors. It's also the foundation for generative models of agent behavior that we use for simulation. And that brings me to the second key challenge of autonomous driving, just beyond the building of a good driver, and that's evaluation. Now, key to good evaluation is a good simulator. So what makes a good simulator? Well, first of all, it needs to be able to run at very large scale, simulating billions of miles. Second, it needs to be able to run in closed loop, meaning that if you take an action in this simulated world, the world responds appropriately. And third, it needs to be realistic, both from the perspective of sensor realism, as well as from the perspective of behavioral realism, meaning that all of the simulated agents, all the simulated road users are behaving the way they would in real life. So we have a bit of an interesting chicken and egg problem, right? To build a good driver, you need to build a good simulator. And to build a good simulator, you need to create realistic models of pedestrians, cyclists, and other vehicles. So in many ways, these two key technical pillars of the AV problem actually share the same technical foundation, and we've made some really great strides in the Waymo AI to power both. So let me show you a couple of examples of the work that we have been doing in simulation. Here's one example where we created a dense 3D reconstruction of a block of San Francisco at scale using millions of camera images. And once we have that model, then in simulation, we can generate all kinds of different versions by varying the time of day or weather and other environmental conditions. And we've pushed this line of work further and used diffusion techniques that are commonly used in video generation to give us fully controllable models, where not only can we control the global environmental properties of the scene, as you hear here, but we can also add or remove individual objects, allowing us to generate and simulate a whole number of new dynamic traffic situations for the purpose of training, evaluating, and testing the Waymo driver. Now, all of these components, sensing, AI, simulation, and evaluation, come together to give the Waymo driver truly superhuman performance. Let me show you an example. This is from San Francisco. It's a fairly nominal situation. We're waiting at a red light. There's a bus that crosses in front of us. So let's see how this goes. Our light turns green. We proceed. And notice, we are detecting a pedestrian on the other side of the bus. But we completely occluded to a human driver. So what's happening here is that our sensors are able to pick up the movement of the person's feet under the bus. And just that little bit of noisy and sparse signal is enough for the Waymo driver to detect that there's a pedestrian there, and furthermore, to predict what they're going to do in the future, allowing us to take defensive action early, keeping everyone safe. So all of these AI advances have tremendously accelerated our progress, making the Waymo driver truly generalizable. Here are all the places where we've tested over the last couple of years beyond our mature commercial markets. It includes everything from snowy upstate New York to the left-hand side traffic in Tokyo. And with the help of AI, the Waymo driver is learning fast and adapting quickly to all of these different environments. And not only is the Waymo driver generalizing well across different geographies, it is generalizing well across different vehicle platforms and across different applications. Today, we're very focused on ride-hailing. In the future, the Waymo driver will power all kinds of products, all kinds of commercial applications, from local deliveries to long-haul trucking to personal vehicles. By 2030, total vehicle miles traveled is projected to reach 20 trillion. Just imagine the impact that the Waymo driver will have taking all of these opportunities together. But across every use case, one thing remains constant for us, and that's trust. It's core to what we have built, and it always will be. And trust doesn't just happen overnight. Trust is earned with every mile we drive, with every ride we serve, with every bit of technology that we deployed. And the thing that makes us happy is our happy riders. So let's hear from them directly.
What are we doing?
We're in our first ever Waymo.
And what does it mean when we're in a Waymo?
It means that there is nobody
Driving this thing!
And this is a fully autonomous Waymo ride.
I cannot believe this. The car did a better job than if somebody was driving.
The truck was over the yellow line, so the Waymo braked and moved to the side.
It knew how to pronounce my name.
Oh my God. Look at this thing.
Wow, it's nice. I love it. This is new.
This is so cool. I'll never forget this. Never.
Makes me want to go into a Waymo right now. Thank you so much, Dmitri, for that look inside this fascinating technology. A reminder to the audience, have your questions prepared. You can start lining up on either side of the stage at the mics. While you think of your questions, I have a couple of my own to start us off. You spoke about how AI has really turbocharged the acceleration into an expansion to new cities. Can you go into more detail about how things are different now compared to 5 years ago?
Let me start with the second part of the question. Because 5 years ago, things were qualitatively different. Actually, 5 years ago in 2020, we had just begun to offer our fully autonomous service to the public, and it was in the East Valley of Phoenix in a city called Chandler. But that was on the fourth generation of the Waymo driver, the previous generation. And while we were with that deployment, we were learning all the million things that it takes to actually operate a 24/7 commercial service. On the technical side, we were doubling down on making a leap from the fourth generation to the fifth generation, and the fifth generation is what we see on the roads today. And by far the biggest delta from between those generations was our aggressive big bet on AI. Right? And that really paid off with all of the safety performance that we talked about and the pace of scaling that we're seeing today. Now, in terms of the specific role that AI plays in generalizability and going to different cities and going to different geographies. I would say that I primarily don't look at it from the perspective of cities or zip codes. We primarily focus on the capabilities of the Waymo driver. So we have this term, the operating domain or operating design domain is basically the set of all of the features in the environment that we deem the Waymo driver to be fully ready for a fully autonomous operation. Right? So now if you look at it through that lens, there's cities and then there's cities. Right? Given where we are today, look at the operating domain and all the capabilities of the Waymo driver across weather, across different cities. When we are operating in San Francisco, LA, Phoenix, Austin, there's many cities that fall today kind of squarely into that operating domain where we already have a robust performance and confidence in the Waymo driver. Take, for example, Atlanta. Right? And those cities, it's all a matter of validation and confirmation, and we find that we show up and it kind of works out of the box right away. And then there's other cities, like Tokyo, where we do need to expand the operating domain. And we do need to teach the Waymo driver, for example, to drive on the other side of the road, or maybe the traffic lights or the signs are a little bit different. And there, we're finding that the big bet on AI is really paying off because just give it new data, and it learns incredibly well and incredibly fast. And it's, if you think about it, it's actually not that counterintuitive, because if you show up to a new city, what are the hardest problems in autonomous driving? Well, it's not detecting the signs and the different color cones. It is the fundamental understandings, right? So when you go up and show up to a new place, pedestrians still look the same. Cars largely look the same. How people interact with one another fundamentally remains the same. So that's what we're seeing, and it's very encouraging. And with time, the operating domain will just expand, and the speed of iteration with all of the amazing progress in AI will just get faster and faster.
What will be some of the most profound, positive impacts of autonomous driving to society?
Well, for the most profound impact, I immediately go back to safety. Yeah. Talked about it again. 1 million lives lost on the roads across the world every year. In this country alone, about 40,000. This is insane. Like, if we invented cars today, there's no way we'd be okay with that. But it goes beyond that. I think not only will autonomous vehicles save lives, they will change our lives in many ways. They will change how our relationship with time, how we experience cities, and so much more. So in terms of time, today, an average American spends about 300 hours a year just sitting behind the wheel. For the whole country, that's about 80 billion hours. Think about all the wonderful things we can do with that time. As the deployments and autonomous vehicles scale up across our cities, across countries, I think the cities themselves will start to change. The streets will change, the parking lots will shrink, and so forth. Another thing that I find, actually, that's maybe the one that is closest to my heart and to many people at Waymo beyond safety, is accessibility and making transportation inclusive, right? I mean, it should be inclusive, but today it isn't. People who are blind, people who have low vision, sometimes they have trouble finding the ride in a busy pickup area. Sometimes they just get rejected because of their guide dogs, or they just don't feel safe. Now, with Waymo, we've designed everything from the ground up, from beginning to end, to be inclusive and accessible. And it can be very powerful. For many things for us, we get our time back. That's nice to have. For many people with disabilities, it's really life-changing. There's a couple that I recently learned about. It's a married couple. They're blind. They live in Phoenix. They have not been in a car together alone for more than 30 years. And today they use Waymo. They love it. It gives them the freedom of mobility without needing to rely on other people. So that can be life-changing for many people. And I guess maybe the last thing I'll say is that today, with the trillions of miles that we're driving and only increasing, there's so many aspects of society that rely on that foundational layer of moving people and goods around that once there's autonomy across that stack, I think we'll see all kinds of new applications, all kinds of new benefits that pop up over time.
So many positive repercussions. Dmitri Dolgov, thank you so much for your time.
Thank you.